Today I'll discuss an important topic regarding the use of spatial big data, how geographically and socio-demographically representative of the population are new forms of mobile phone data. The overall objective of this short talk is to compare the coverage of mobile phone users and socio-demographic data from public and private sources. To do this, we first estimate home location of users based on an advanced home location detection technique, which utilizes high-resolution land use data, including residential locations. I'll be talking about two mobile phone datasets today, which contain data generated through the use of mobile phone applications. Both datasets have coverage for 3 years across the Glasgow city region. This is the extent of the study area, the Glasgow city region, with a call out to Glasgow city, and an example of how the data looks for 1 month. To estimate home location of each mobile device, we use an activity heuristics approach with enrichment of the data. After enriching the GPS data with high resolution land use data, we assume that the home region of a mobile device is that area where the user maximizes evenings in residential space, where an evening is assumed to be between 8 p.m. and 6 a.m. Here are the home location results. Although there's some variance across years, we estimate a home location for around 1/3 of the users in each year. You'll notice that the number of users in the Tomoko dataset is much larger than that of Huck. This is because we only have monthly identifiers for this dataset and therefore re-estimate a home location on a monthly basis. If we look at the volume of data in the datasets, which is generated by those users which we can generate a home location for, we find that users with a home location generate around 80 to 90% of the data, meaning we have home locations for almost all of the data in both datasets. This also means that a large number of users are generating a small amount of data, those who we cannot estimate a home location for, because they have no residential data. Before looking at the socio-demographic comparison, we can look at the coverage of mobile phone users to that of the working population in 2020 across the Glasgow city region. This area has over 2,300 data zones, which account for over 1.8 million people. In this area, Huck has a 0.7% coverage, compared to Tomoko, which has a 1.1% coverage of the working population. So first, comparing the number of mobile phone users with the working population across deciles from the Scottish Index of Multiple Deprivation. Here, 1 represents the least well-off areas and 10 represents the most well-off area. Labels show the ratio to the working population, where 1 represents an equal percentage coverage for mobile phone users and from the working population. Generally and positively, what we find is an almost equal coverage across different decile groups throughout the Glasgow city region for both datasets. When we take this result 1 level deeper to the percentile level of SIMD, this strong relationship holds across both datasets, with a strong correlation between the mobile phone population and the working population across the 100 percentiles. Second, comparing the number of mobile phone users with the population across area types from the private khaki acorn consumer classification. Here, the titles of the categories are self-explanatory. Labels show the ratio to the population, where 1 represents an equal coverage from mobile phone users and from the population. And again, across the Glasgow city region, different types of area are well represented by both mobile phone datasets in 2020. Finally, we can take the private comparison 1 level deeper to the 62 categories of the khaki acorn classification. In doing so, we find a strong correlation between the population and the number of mobile phone users across the different socio-demographic groups. So we believe these results represent a solid foundation upon which research using these forms of mobile phone data can build. And thank you for listening.